Okay, so now tangent's a little bit harder because it's not so obvious where they are. So again, I always think of it as sine over cosine. Inverse. Okay, so we have that this is equal to, so we want to know when the sine of x over cosine of x is equal to minus the square root of 3. Well, we don't have a square root of 3, but what if I do this and put them all both over 2? Now that looks more familiar, right? Because I have minus the square root of 3 over 2 over 1/2. And we know there's a point where that exists. What's the reference angle for that point? Who am I up to? I'm up to Michael. Michael, what's the reference angle for this point? That's not the reference angle, Griffin. What's the reference angle? Michael T, do you know the reference angle? This is an actual point, right? When sine is equal to square root of 3 over 2 and cosine equals 1/2. Pi over 6. Nope. Pi over 6 is square root of 3 over 2, comma 1/2. So here the cosine equals square root of 3 over 2. No, Zachary, I'll get to you, I promise. You're almost up. I have plenty of work for everybody. No worries. So we want the one where the cosine is equal to 1/2 and the sine is equal to square root of 3 over 2. Right, Michael? So which point is that? I just want the reference angle. The reason I want the reference angle is because so far everybody's giving me the wrong answer. I just want the reference angle. Everything's positive. Everything's positive. What's the angle? What's the angle for this? Do you understand my question, Michael? Okay. I know you know it. Positive. It's positive. Everything's positive. In quadrant 1, the reference angle is always in quadrant 1. Don't be surprised if every single test and quiz you have there's a reference angle question on it. I want you to know how to find reference angles. You've better get up on it because you need it. That is the reference. What quadrant is that in? What quadrant is 2 pi over 3 in? Quadrant 2, right. Reference angles are always in quadrant what? 1, exactly, so it can't be right. So what is the reference angle? Pi over 3, exactly. So my reference angle is pi over 3. Where is the inverse tangent defined? Do you remember, Michael? I know I just told you. Think about it. Think about it like this. It's the same place the sine is defined, between negative pi over 2 and pi over 2. Sine and tangent are defined in the same place. Okay? So could the answer be 2 pi over 3? No. So what is the answer? Do you know? I mean, I don't want to put you on the spot if you don't know. I'm trying to walk you to it. What quadrant does it have to be in? It can't be in quadrant 1 because in quadrant 1 it's not negative. 4, exactly. So it's got to be in this quadrant. So we know now the quadrant and we know the reference angle. So what's the value? What's the answer for A? Once you know the quadrant and the reference angle, you should be able to come to the point that the answer. So remember, tangent is defined between negative pi over 2 and pi over 2, right? So what's the answer to this problem? Exactly, negative pi over 3. Boom. Okay, did you get it? Okay, good. I'm just, you know, I feel like if I walk each one of you through it, everybody learns from one person being walked through it. Is that true or false? Are you all learning while we do this? Okay, good. Okay, good. Okay, let's do B. Who's next? Red one. As long as you guys work with me and you're not scared to, I'm good with that. I think it's the best way for you to learn. Otherwise, I'm just saying a lot of stuff that you don't understand. I know it does. I know it does. That's why I want to give you, I just want to walk you through it. I know it does. Believe me. It kind of does me, too. Because I'm always on the spot. Like, have you noticed I make mistakes? I mean, sometimes my mouth says something and my hand writes something completely different, or vice versa. So, yeah, I get it. Don't worry. I got you. Okay, let's see. Red one. How about B? Are you there? Okay. So how would I do B? I know this is kind of a weird one, but it's kind of easier, believe it or not. Okay. So how do we know what quadrant that's in? Well, remember I showed you before, let me see where I did that. Hopefully I didn't erase it. Yeah, here. So remember we talked about this is 0, this is pi, which is the same thing as 3.14, right? This is pi over 2, which is the same thing as 1.57. Remember this? Okay, so now we're going to use that. So where would minus, what was the number? Here, where is minus 0.89? Where, so do you know what quadrant that, what if it was positive? Where would it be? Let's say it's positive. No, let's say it's positive. It would be in quadrant 3? Well, it could be, but where would be the more obvious place for it to be? I'm giving you this circle. Look at the circle. So here. I was wondering what happened, Bianca. No problem, no problem. Don't you love it? Okay. So, you know what? It's happened to me in the middle of a lecture. So, I get it. If ever I disappear, it's not on purpose. I'm sorry, guys. I know this is your 6th time in, Damien. You see that number next to you? No. That's okay. All right, so red one, back to you. So calm down about the test. You have a lot more. Right now, you have to be in the lecture. So where would, if I show you this picture, where is 0.89 on this graph? Positive 0.89. How do you get that? Do you have a microphone, red one? No. So if I tell you that this is 0, and I tell you that this is pi over 2 is the same as 1.57, then where would 0.89 be? Richard, where would 0.89 be? In quadrant 1.
It would be in quadrant 2. Sorry, quadrant 1.
It's got to be in quadrant 1. I just said it's between, isn't 0.89 between 0 and 1.57?
Right.
Yeah, so it's got to be in quadrant 1. So now, if it's negative, it's going to be in what quadrant? Yeah, I'm not trying to ask you really easy questions. Don't make this harder than it is. So if it's negative 0.89, what quadrant would it be in?
Are you still asking me or red one?
No, I'm going to ask red one. I'm coming to you next. You were just next on the list. Sorry, Richard. But be ready. I'm coming to you next. So it'll be in quadrant 4. Where is inverse tangent defined? Same as sine. Yeah, so these just cancel. The answer is just 0 minus 0.89, 0.89. Because it's in the right quadrant, we don't have to move it. Does that make sense? Is everybody getting this? Does anybody have any questions? Okay. We're all good? Okay. Now, these are a little different. What is minus pi over 2 or pi over 2? It's between those two, not one or the other. It's between those two values, yes. Okay, good. All right, so now, okay, Richard, you're up. So this is just, it's not harder, it's just a little different. Because the first thing I want to know is where, so let's make a circle. Where is, let's use reference angles. Where is the sine equal to 1/2? Where on the unit circle is the sine equal to 1/2? What's my angle that gives me that? Richard, I'll take you.
Let's see. Give me 1 second to think about it.
Yeah, no problem.
Pi over 3.
Nope.
Then it's pi over 6.
Right. You guys got to get this. So look, the sine is the y value. Pi over 6 is the smaller angle. Notice that y is smaller than the x. At pi over 3, the x is smaller than the y. Just remember it like that. It'll be easier. See the difference?
Yeah, sometimes I confuse sine and cosine for x or y.
Oh, I see. So it's not that, it's the x and y. Okay, got it. Let me think, how can I help you with that? I mean, how about x is smaller than y, and like alphabetically, and cosine smaller than sine alphabetically?
Right. I mean, if I'd written it out, I probably would have gotten it. I was
okay. No problem. No problem. Okay. I don't mean to make you crazy. I'm just trying to. So we said it was at. So the reference angle is pi over 6, right?
Right.
And what quadrant would the sign be negative, or the inverse sign be negative?
Quadrant 4.
Perfect. So what is the arc sine of -1/2?
Negative pi over 6.
Perfect. So now we know we're here, and we know the values, right? We know the values of pi over 6. There, the cosine is equal to 3/2. Sine is equal to -1/2. Right?
Yes.
So what would the tangent of minus pi over 6 be? You don't have to simplify it. Just give me how you would start.
It'd be negative 1/2 over square root of 3 over 2.
Perfect. And then, honestly, you can just look at it like this, because you're going to flip them and everything. These are canceled. I can multiply by 2 over 2, whatever you like. So the answer here is -1 over the square root of 3. And you do not have to rationalize, but you can. And that's the answer. Good job, Richard. You get it?
Yeah, so the fact that the 1/2 was negative for arc sine doesn't matter?
It does. It puts it in quadrant 4.
Oh, okay. So if it was
was
positive, then it would be in
quadrant 1, right?
Yeah, okay.
Okay? Good. All right, who's next? Oh, Savon, you're up.
For B?
B, yes. So what's the cosine of pi over 3?
The cosine of pi over 3 is root 3 over 2, right?
Nope. You guys have these all backwards. Pi over 3 is the taller of the angles. That means that the x is smaller than the y.
Right.
Which one's smaller, the square root of 3 over 2 or 1/2?
1/2.
Right. So the cosine of pi over 3 has to be 1/2. Because the x is smaller.
Right.
Does that make sense or no? You sound confused. Let's do it again. I have too many angles there. So pi over 3 is this one, right?
No, it's pi over 6, isn't it?
No, pi over 6. The smaller the denominator, the bigger the value.
Okay.
This is pi over 3. This is pi over 6.
All right.
Okay?
Okay, that makes sense then. So then the cosine of pi over 3 then would be 1/2.
Good. And then what's the inverse sine of 1/2?
Inverse sine of... You said no calculator, right?
No calculator.
Okay. The inverse sine would be cosecant, right?
No. It's so when you take the cosine, notice here, when you take the cosine of an angle and you get a value, right?
Right.
When you take the inverse, you take the inverse of a value and you get an angle.
Right.
You have to give me an angle back. Where does the inverse sine, like, so basically I'm asking you the sine, I don't know what's happening again. The sine of y, oh great, now my pen is doing that weird thing again. Hold on. Hold on. Okay, let's see if I can if it works now. Okay, I'll do it like this, just for a second. Hopefully it'll undo. Y equals the sine, no, sorry. The sine of y is equal to 1/2. So where is this, what is y such that the sine of y is equal to 1/2?
So where is... Wait, what was the question again?
What's y? Where does the sine of y equal 1/2? What's the angle? I need an angle such that the sine of that angle equals 1/2. You got to get your unit circle down, Savon.
No, I have it down. It's just I didn't realize what the question was. Okay, so the sine of that then would be equal to 1/2. The sine of that equals 1/2 would be pi over, no, not pi over 3. Would be 60 degrees, right?
Don't do degrees, do radians.
Oh, radians. Okay.
We very rarely talk about these trig functions with degrees. Don't get used to it. Get used to it the opposite way.
Okay. Radians.
I don't even know if we use degrees anywhere in calculus.
Interesting. Okay, so instead of 60 degrees, instead that would be so
too long. Pi over 6. Too long. Taking too long. You can't take that long. You won't finish your tests.
Right.
These have got to be wet. Remind me on Monday when I see you. We're gonna do like not flashcards, but kind of like me. I'm gonna do flashcards with you. I'm gonna flashcard you.
Because things I was getting confused between the unit circle that you had up and between the unit circle that I already memorized.
Same unit circle. You
Right.
memorized it wrong if it's a different unit circle. Yeah, Griffin.
I don't know if this is like the best way to do it, but I just remembered like the radians, because if you just do 180 divided by 3, it's 60, and 180 divided by 4 is
Yeah, but
45.
you're still in degrees.
Yeah, but I was just talking about like so you don't get those confused, like the pi over 3 is at top. Like I just know.
I understand, but what I'm trying to say is, if you have pi over 3 and you have pi over 6, which one of these numbers is bigger? If you have 1/3 and you have 1/6, which number is bigger?
Pi over 3, so 1/3.
1/3. What's bigger, 1/10 or 1/100?
1/10.
What?
1/10.
Right. The bigger the denominator, the smaller the number.
Yeah, now I see where I went wrong, because I confused the radians with degrees, because I was correlating.
I mean, we're going to use degrees, but degrees is the least of your problems, any of you.
Right.
Radians is. Try to only talk in radians unless the problem is in degrees. Like, always answer in radians just to get your mind. It's like we're trying to learn a new language, and the only way to do it is to immerse yourself in it. If you were trying to learn Spanish, and every time you wanted to say a sentence, you thought about it in English, translate it into Spanish, and then said it. First of all, it wouldn't be a very good way to learn Spanish, and second of all, often it comes out wrong, right? Right, Luis? I'm going to guess you speak Spanish. Oh, he's not here. I mean, I guess we speak Spanish.